This one looks more complicated. Y equals negative 3x minus 2. So let's just start the same way and pick an easy value for x. If x equals 0, I'm going to write my equation, negative 3x minus 2. I'm going to write it again. I'm just going to substitute 0 for x. Our variable x has a value of 0. Negative 3 multiplied by 0 minus 2. PEMDAS, I need to multiply first before I subtract, and so negative 3 multiplied by 0 is 0. So y equals 0 minus 2. And we remember the definition of subtraction. Subtracting is the same as adding the opposite. So 0 minus 2 is the same as 0 plus. Subtracting is the same as adding the opposite. We were subtracting positive 2. That's the same as adding negative 2. And 0 plus negative 2 is just negative 2. So y is negative 2. Some of you can look at 0 minus 2 and just know that it's negative 2. And you don't have to change it to addition. But I'm just reminding you that we've done it both ways. So this one does not pass through the origin. For this linear equation, when x is 0, y is negative 2. So that line intersects the y-axis at negative 2, not at the origin. I'm going to pick another value for x. I'm randomly choosing one. I'm just choosing an easy number to try, like positive 1. If x is positive 1, I write my equation, y equals negative 3x minus 2, and I substitute positive 1 for x. Y equals negative 3 multiplied by positive 1 minus 2. Negative 3 multiplied by positive 1 is negative 3. So I have negative 3 minus 2. Some of you know that's negative 5, but if it helps you to change it to addition, we're just going to do the same thing we did before. Subtracting is the same as adding the opposite. I was subtracting positive 2. It's the same as adding the opposite of positive 2, which is negative 2. And negative 3 plus negative 2 is negative 5. So when x is positive 1, y is negative 5. So our ordered pair is positive 1, negative 5. When I graph that, I start at the origin. Origin means starting place. I have positive 1 for x, so I move 1 to the right in the horizontal direction. And my y value is negative 5. So from there, I move down 5. And there's 1, negative 5. I'm going to do now a negative input. Let me just go with a bigger, like negative 2, or actually smaller, right? If x is negative 2, write my equation, negative 3x minus 2, substitute negative 2 for x, negative 3 multiplied by negative 2 minus 1. Negative multiplied by negative is a positive, so negative 3 multiplied by negative 2 is positive 6. And 6 minus 1 is just 5. So sometimes the negative input actually gives you an easier computation. It just depends on the function. If our input is negative 2, our output is positive 5. So negative 2, positive 5. And just like we've done all year, there's almost always, I want to say always, but I can't imagine every possible scenario, but I feel like there's always, or at least almost always, a way to think about whether your answer is reasonable when you're doing math. And so I expect, I can sort of visualize this line even though I haven't tried to draw it yet, and I expect this third point to be somewhere on that line. So when I graph it, when x is negative 2, when I move 2 to the left, and then y is positive 5, so I move up 5, and I plot that point, it's where I expected it to be. It seems reasonable because my line through these 2 points was going to take me up and to the left in a kind of a steep kind of a way. And so I expect that third point to be on the line. It would have to be on the line, right? It would have to match the relationship that this linear function, this linear equation is describing.